Let's go ahead and do this problem, or at least show how it's done. Our function h of x equals x to the third on the closed interval from 0 to 5 using 10 rectangles with midpoint rule. So we are going to calculate this Riemann sum with those parameters. The first thing that we're going to do is calculate our width, or in other words, our delta x. Our width here is going to be what you get when you take 5 minus 0, all divided by 10. That means each rectangle is going to have width of 0.5. In this case, before I write the general Riemann sum, I'm going to create my subintervals so I don't have to go back. My subintervals are going to be, since I'm starting at 0, the first one is going to go from 0 to 0.5. The next one is going to go from 0.5 up to 1. The next one is going to go from 1 up to 1.5. You don't have to write all of these if you don't want. You can see the pattern now, and therefore, if you're going to keep going all the way until you reach 5, your last couple of intervals are going to be from 4 to 4.5, and then from 4.5 to 5. The Riemann sum I get by taking the actual summation. Let's take the summation from I equals 1 to 10, because I use 10 rectangles here. In this case, it's going to be h of the midpoint, I'll fill that in a second, times delta of x. Some people will just write the midpoint as m sub I. Other people will write out the fraction. How do you get the x? X sub I plus x sub I plus 1 over 2. So you can write the midpoint like that. I think I'm just going to write m sub I for midpoint. Or if you'd rather, it's not that big of a deal if you write x sub I, but you know that that's a midpoint. I think I'm going to write m sub I just so I can have my midpoint. And then obviously we've already said in this situation, delta x is size 0.5. That is the shorthand version of the Riemann sum. The longhand version forces me to go through and calculate all of these. That means I'm going to take h of the first midpoint. Notice that the midpoint of the first subinterval is 0.25 multiplied by 0.5 plus h of, notice the second subinterval has midpoint of 0.75 multiplied times 0.5. The third, 1.25, is the midpoint for the third interval. That means I'm going to plug in 1.25 into my function and then multiply times 0.5. And this pattern keeps on. Notice that when you go from one to the next, each jump of a midpoint is a jump of size 0.5 because that was the size of my subinterval. So I can keep this pattern going. H of 1.75 multiplied times 0.5 plus H of 2.25 multiplied by 0.5 plus H of 2.75 multiplied times 0.5 plus H of 3.25 multiplied by 0.5, and so on and so forth. I continue to write. You can see that there's quite a few rectangles that I have to find the area of, 10 to be precise. Each one of them has width of 0.5 using the midpoint rule. I can do the same trick I did last time and factor out a 0.5 and then add all 10 of my heights together. I'm going to do that in this manner. This does take a minute, as you can clearly see. But it is shorter than some other things we could do. There you go. At this point, I have to remember what my function is. My function h of x is x to the third. Now, in the next 5 seconds, I am going to just replace each of these function values with the actual value, meaning when I input 0.25 into the function, it will give me 0.25 cubed, and I'll replace the 0.25 cubed with the appropriate decimal or fraction. So I'm going to do that in just 2 seconds. And there, I've done it. Now, I used fractions here because it turns out when you utilize improper fractions, you're dividing by 64 each time, and these fractions are really easy to add up. You can add 1 plus 27 plus 125, and so on and so forth. And then divide my final answer by 64, since each of them have a denominator of 64. And then once I get that, I multiply by 0.5. Again, I liked to use fractions there just because it's a little bit easier to see and a little bit easier to do than decimals in this case. A lot of these decimals are pretty ugly looking, rounded to 6 digits or so. I should say they go out to 6 digits or so. When I calculated this, I ended up with an answer of 155.46875, which is also 4975 over 32 in improper fraction form. This is the Riemann sum approximation of the area under h of x equals x to the third from 0 to 5 using 10 rectangles. Again, I've tried to utilize some algebraic tricks to make my writing a little bit easier, but you don't have to do that if you don't want.